Hello, welcome to Math Lessons with Linda. Today's topic is going to be arithmetic sequences, and a sequence is just a string of numbers that are somehow related by the same pattern. So today we're going to talk about arithmetic. So here are the beginning terms in our arithmetic sequence: 7, 16, 25, 34, the dot, dot, dot means the pattern continues in the same way. So for an arithmetic sequence, what has to be true is that to get from one term to the next term, you have to be adding the same value. And I will note that when you are adding, sometimes you are adding a negative number, so it might appear as if you are subtracting, but we'll say we're adding a negative. So on this one, I can actually work backwards and do 16 minus 7, which would give me a plus 9, and 25 minus 16, also a plus 9. All of these differ by plus 9. That's how I get from one term to the next. So that value we label as D. D is the common difference between our terms, and that's an important value to write our formulas for finding additional terms. So there are two things that we can write an equation for an arithmetic sequence. One of those is called recursive. So the recursive formula is the less helpful of the two because we can only use the recursive formula to find the immediate next term and then the next term after that. And it's in two parts. So a sub 1 is the first term that's in my sequence, which we already know that is 7. Now, if I want to get like the next term, so let's say we'll call that our a sub n, but we're going to say like, what if I want to find the second term? Well, what I have to do is I have to use the a n minus 1 term, which that means 2 minus 1. I'm trying to find the second term. That means, hey, use a sub 1, so that would be this term. And then to get the next term, just add 9. So my recursive formula looks like this. It's in two parts, and it says, hey, start with the first term, and then to get the next term, add 9 every time. So that's a slow process if you want to get to, say, the 50th term in your sequence. So we have another type of formula that we can use for the same problem, and this is called the explicit formula. Now, the explicit formula will help you find any term without having to find them all in order. And this is what the general form looks like. Again, it's a sub n for whichever term that you would like to find. We start off with whatever the first term is. Then we add d, which remember that was our difference, times n minus 1. So this is the general form for an explicit arithmetic sequence. And now we're going to find what that formula looks like using our values that we already know. So if I want to find any term in my sequence, I'm going to start with 7. And then my d is 9. And then n minus 1. So here I'm going to want to distribute this through. So I'm going to have 9n minus 9. And I can actually combine these two terms, and my explicit formula looks like this. I'm going to put my n term first. So 9n, 7 minus 9 is going to give me minus 2. So this explicit formula will let me find any term in my sequence. So let's do one like that real quick using our formula. Remember that we had our sequence up here with the first 4 terms. So let's go and use this to see if we can find the 10th term. So a sub 10. So I'm going to plug in here 9 times 10 minus 2. So 90 minus 2 should give me 88. So the 10th term in my sequence up here, a sub 10, should equal 88. Now, does my answer make sense? Probably, because these numbers are getting larger, and by the time I get to the 10th term, I should have fairly large number compared to these. And if you want to check yourself the first couple of times, just go through and do it with the recursive, right? Add 9, keep doing that and see if this answer matches up. And if it does, then you have used the explicit formula correctly. So that's an example of how to use arithmetic sequences with both the recursive and the explicit formulas.